This is Unit 11, Lesson 3, and we are verifying trig identities, Part 1. So this is the most basic trig identity. In Lesson 1, we talk about how we actually formed this, and from this we can come up with other versions of this. So I'm going to take this first one, and if you've forgotten this, I'm going to take this very first one. It doesn't matter if I start with sine or cosine. I'm going to divide all three terms by sine squared. As long as I do the exact same thing to everything, it's not going to change the original function. Sine squared divided by sine squared is simply going to be 1. I know that cosine squared divided by sine squared is cotangent squared, and 1 divided by sine squared is cosecant squared. And I didn't have to memorize anything. In my mind, that's the only thing I'm memorizing. Okay? I'm going to come back and do the exact same thing. I'm going to go sine squared plus cosine squared equals 1. And now instead of dividing by sine squared, I'm going to divide by cosine squared. Divide by cosine squared, and cosine squared. Sine squared divided by cosine squared is going to be tangent squared. Cosine squared divided by cosine squared is 1, and 1 over cosine squared is secant squared. Now, what I want to also review before I go any further is when we look at that very first equation, there's other ways we can write it. So I'm going to go down below, and if you don't have these on your paper, please go ahead and do this. So I want to talk about different variations of this first equation. For instance, I could isolate sine squared, and it would be equal to 1 minus cosine squared. I could isolate cosine squared, and it's going to be equal to 1 minus sine squared. Thumbs up or thumbs down if that makes sense to you. Okay? Also, let's do that over here. I could do other variations of this. So I could have that cotangent squared is equal to cosecant squared minus 1. And we could do 1 minus cosecant squared. That's different than this. 1 minus cosecant squared is equal to negative cotangent squared. And you're like, how did you get that? For those that are visual learners, I'm subtracting cosecant squared to the other side, and then I need to subtract cotangent squared to the other side. So it's just a way to manipulate mathematically different equations. We could do the same thing here for tangent. If I wanted to isolate the tangent, tangent squared is equal to secant squared minus 1, and hopefully you understand all of these. Now, the other ones we talked about, and you can see them on the board to the left, is sine is equal to 1 over cosecant. Again, cosecant is 1 over sine, and so on with the other trig functions and their reciprocals. Let's get started with the very first example. Please write down this very first example. So we are going to use the skills that we practice in Lessons 1 and in Lesson 2 to verify or prove that the left side equals the right side. We're going to go to that paper in which we just practiced the different forms of these trig identities, and we're going to apply them. How can we get the left side to equal the right side? How do we get the left side to equal the right side? So we have more than one way of doing this. Please look into your packets right now, which I asked you to have out. Look at Lessons 3 and look at Lessons 4. Notice there is no answer key because there's more than one way to do this. Generally, there's a simpler way. I specifically remember there was a problem last year. Thank you, I didn't see you here. I remember there was a problem last year, and I tried multiple times. Like, I'm going to say I tried 3 or 4 times, and I just couldn't get it. Miguel had it in like 30 seconds, and he showed the class. I'm like, oh my goodness, I just didn't see that pathway to proving the left side equals the right side. So let's get started with, how can I show that the left side equals the right side? Well, let's start here, and I'm just practicing here. I'm going to come off to the side, and I'm going to be lazy here. I'm going to write down sine equals 1 over cosecant. I know cosecant equals 1 over sine. I'm going to write down cosine equals 1 over secant. Tangent equals 1 over cotangent. And then this, I think, is going to be more important. Tangent, and sometimes students forget this, is sine over cosine. How many of you forget whether tangent is sine over cosine or cosine over sine? How many of you forget that? It's a common thing. And we know that cotangent is reciprocal, cosine over sine. Okay, what am I going to do? Well, I'm going to just try here. My gut says, let's see if we can isolate the tangent. So if I have to isolate tangent, that means I need to move cosecant to the other side. Cosecant is being multiplied by tangent, so let's divide by cosecant. So tangent is now isolated, and I'm going to write this out horizontally instead of vertically. I'm going to write secant divided by cosecant. And then I'm going to replace secant with what it's equivalent to. I know secant is equivalent to 1 over cosine, and I know cosecant is equivalent to 1 over sine. We need to continue showing the left side equals the right side. Okay, remember when we divide fractions, we keep the first fraction in place, we turn division into multiplying, and I take the reciprocal or flip the second fraction. When I multiply across, I get sine over cosine, and sine over cosine is equivalent to tangent. I just proved the left side is equal to the right side. So when I see this, I think about combining like terms. And so you're like, well, what do you mean like terms? I see cosines here and I see sines here. Let's try to combine them. So I'm going to move the cosine to the opposite side. So these cosines are additive inverses. They cancel, and I have negative sine squared x equals, okay, negative 2 cosine squared x minus, I'm going to put them right by each other, minus 1. So when I combine like terms here, 2 cosine squared minus 1 cosine squared is just 1 cosine squared x minus 1. Now there is more than one way that you can go about doing this. And so I would most likely stop right now because I recognize, I want to show you, but I'm going to give you an alternate way of doing this. So it's a little bit longer, but watch. Come up here. If I want to turn sine squared in this equation into a negative, do you guys agree I'd have to subtract to the other side? Does everybody see that? Okay, thumbs up or thumbs down. Does everybody see that if the sine squared comes over here, it's negative? Thumbs up, thumbs down. So I'm going to come over here and do this one. So over here, I bring sine squared to the right-hand side, it becomes negative. And then cosine squared is still hanging out here by itself. Well, if the 1 joins it, I have to subtract. So does everybody see how negative sine squared x is the same as cosine squared x minus 1? That's what I have right now. I have cosine squared x minus 1 is equal to negative sine squared x. They're exactly equal. So I could say, hey, I know this is the same as negative sine squared. Okay, I know this is the same as negative sine squared x. And now the left side equals the right side. You may be saying, remember, this is why there's not an answer key, because there's more than one way. You may be like, Miss Bradley, I'm not at that point yet. Is there another way I could still achieve this answer? I think there is. Let's take this sine squared and let's move it to the right-hand side. When it moves over, it becomes a positive. So it moves over, it becomes a positive. And then I have a cosine squared. And then I'm like, hey, let's move the 1 to the left-hand side. Well, it's negative. When it moves over, it becomes 1. Isn't this the most basic trig identity that we're memorizing? And so I could replace sine squared plus cosine squared is equal to 1. So I know this equals 1. As long as we get the left side to equal the right side, we've accomplished the goal. We've verified the left side equals the right side. Please do me a favor and write down this third example. I'm going to come off the side and I want to show you, because sometimes when we have trig functions, it just seems more complicated. So if you could look over here for 1 second. If I said to you 4 minus 5 over 4, another way that you could think about doing this is this 4 must be shared with the left and the right. So this is 4 over 4 minus 5 over 4. So 1 minus 5 over 4. It's another way for us to manipulate numbers correctly. Let's do the same thing here. This cosine must be shared with the left, and it must be shared with the right. So let's write this as cosine of x over cosine of x. Bring down the plus sign. And now I'm going to write sine of x over cosine of x. Get ready, tutors. You're going to lead the next example. Get ready, okay? So cosine divided by cosine is 1. I recognize that sine over cosine is equivalent to the tangent. And now I have the left side equaling the right side. Done. Can I have right now a thumbs up or thumbs down? It's okay to feel overwhelmed. We're taking 2 days on this lesson. We're going to talk about, if you're not live with us now because you're missing class, we're going to talk about multiple ways to achieve verifying the left side equals the right side. So David right now is going to demonstrate the way that worked for him. Go ahead, David.
So I just cross multiplied, so sine times sine is just sine squared.
Okay.
And then I multiplied 1 minus cosine and 1 plus cosine. And then I kind of knew in my head that would equal 1 minus cosine.
So he's multiplying these two quantities right now. Mm-hmm. Yeah? Okay.
And then if you just do it, if you just like FOIL it, so 1 minus cosine theta, and then 1 plus cosine theta, that gets you 1.
So he's foiling right now. Yep.
and then these would cancel out, and I'll just be
The insides and the outsides are additive inverses, so negative cosine x, positive cosine x, they're canceling out.
and this identity just equals sine squared.
Yeah, so sine squared equals sine squared. That's one way to do it. Did anybody else do it that way? Very creative, the least amount of work. That definitely trumps my way of multiplying by the conjugate of the denominator. Miguel, did you do it a different way? You did it this way. Nice. So I'm going to use my knowledge of trig functions, and again, there's more than one way to do this. I recognize cosecant is equivalent to 1 over sine. So I have sine of x, really sine of x over 1, times 1 over the sine. Sine times sine, sine times 1, and 1 times sine, and this simplifies to 1. I just proved the left side equals the right side. Let's look right now at our next problem. We have 1 plus the cosecant of x over the secant of x minus the cotangent is equal to the cosine. You're going to realize, let's try a different way. So, what'd you say? It works just fine. We're good. Okay, so the first thing I'm going to do when I look at this is I'm going to rewrite cotangent as a fraction. So I recognize, now I would like you to be writing this down as well. I'd like you to be writing this down as well. In fact, please write this down on number 2 in your packets. This is number 2 from lesson 3, unit 11. Cotangent is equal to the cosine of x or the sine of x. And we don't, this is all on the left-hand side. At this point, I can't combine these fractions. One has a denominator of secant, bless you, one has a denominator of sine. So I'm going to do the butterfly method. I'm going to multiply, and we always multiply going down from top down to the bottom right. So I'm going to multiply these quantities. That's the first thing I'm going to do. I'm going to take the sine of x times the quantity 1 plus the cosecant of x. Then I drop down the symbol that was in between these two terms, and I do the second group, which is the cosine of x times the secant of x. Don't forget, on the bottom, now you multiply the two denominators, which is the secant of x times the sine of x. And eventually, I want to prove that this equals the cosine. That's my goal. So how can I simplify this? Well, let's start here. I know 1 times sine is the sine of x. And then this would be sine times cosecant. So sine of x. And before I write cosecant down, because yes, it's being multiplied by the cosecant, what is the cosecant equivalent to? 1 over the sine. Now I want to subtract. I'm going to take the cosine of x times the secant. But what is the secant equivalent to? You can look on the board if you've forgotten. What is this secant equivalent to? It's equivalent to 1 over the cosine. On the bottom, I'm going to rewrite secant as 1 over cosine of x times the sine of x. Okay, so this becomes a little bit easier. This is sine over sine. Well, sine over sine is simply 1. So I have sine of x, that's this portion. This is sine over sine, which is just 1. This is cosine over cosine, which is just 1, but there's a subtraction sign in front of it. And I can see that positive 1 and negative 1 are additive inverses. They cancel out. On the bottom, I have sine over cosine. We are almost done. Hold on. I have sine divided by cosine in the denominator. Now, instead of writing this vertically, I'm going to write it horizontally. So I have sine of x, and this all has to equal cosine for me to verify. So I have the sine of x divided by, I'm going to write down sine over cosine. Remember that when we divide fractions, we keep the first fraction in place. So sine remains here, turn division into multiplying, and we have cosine over sine. You can see that in this situation, the sines are going to simplify to 1, and I now have the cosine equals the cosine. I have verified this trig identity.